This conference will now be recorded.
Good afternoon, one and all. This is Rajesh from EC department. So in our subject embedded system design, we will cover the next topic of unit 1. So as we have covered these contents, objectives, introduction, definition of embedded system purpose, general purpose computing system, history of embedded system, classification of embedded system, major application areas and purpose of embedded system. We will cover our topic first in last topic, characteristics and quality attributes of embedded system. So the textbook is, as you know, it is Introduction to Embedded System by Shibu KV. So our objective was to define an embedded system. We have defined it. We know what are the basics of embedded systems. We have studied history of embedded systems. We have classified embedded systems. We have seen what are the parameters related to embedded system and the purpose of embedded system. So the introduction part, these embedded systems are utilized in our day-to-day activities without our knowledge. You know, they are built around an embedded system. So what is an embedded system? So as you defined, embedded system is a unique system. It is an electromechanical system doing a specific task. So compared to general purpose computing system, embedded system is having a specific hardware and specific software tailored for a specific purpose, and they are having large number of applications. They are having inevitable products. In every sector, an embedded system is utilized, and your all devices are digitized, and that you can know from its features and the power provided, power and performance comforts of this embedded system. So if you know the power of embedded system, its features, you know how to enjoy the benefits and comforts of embedded system. So this embedded system is a unique system having hardware and software and specially designed for an application. So that application is classified based upon household applications or telecommunications or medical equipment, industrial control or consumer products. So these are the application areas where different embedded systems are designed, and we have seen that in a car there are 3 embedded system logics. One is controlling a headlamp controller by one software program, and a processor will control the headlamp controllers and ignition controllers and airbag control systems. So we can tell our embedded system is an electromechanical system performing a specific function, and it is a combination of hardware and software. So a microprocessor that is controlling an automobile engine, that is an example for an embedded system. So a microprocessor controlling an automobile engine is an example for an embedded system. So there is a hardware, there is a software, there is a RTOS, and it is unique and it is real time, and it may not be real time all the times. Like your electronic toys, it comes under soft real time. Our missile launching system, it comes under real time, hard real time system, and your embedded systems must be deterministic in behavior. Deterministic means they must behave exactly as prescribed by the manufacturer. The user can only utilize the embedded system. He cannot edit the program of an embedded system. He can only, the user, the end user of an embedded system, like your washing machine, air conditioner systems, or refrigerators, or car, or flight control system, or ignition control system, any application you take, robotics, the user can only utilize the embedded system. There is a hardware, there is a software part is controlled by the manufacturer, and an RTOS is going to do the scheduling of the events and assigning the priority. So this RTOS, if it is multiple inputs, if they are coming, it is going to schedule the events occurring and also assign the priority. That is RTOS, real-time operating system, such as VxWorks. So you can tell an embedded system is a system which operates in real time and without human intervention. So these are the examples which we have seen, like your smartphones, digital camera, microwave oven, car, air satellite system, navigation system, refrigerators, toys, traffic light controllers, medical equipment, digital cameras, metro rail, washing machine, DVD players, smartphones. So these all are examples of embedded systems, and thus we can think that there is a hardware having software embedded in it. An embedded system can be an independent system or it can be a part of this large system. See, an embedded system is a microcontroller or microprocessor. So the hardware part can be a microprocessor or microcontroller, and the application software is stored in the memory. Based upon those instructions, it does a specific task, such as a fire alarm. It is an embedded system designed for sensing only the smoke. So an embedded system is having three components. It has a hardware, it has application software, it has real-time OS. What is the purpose of real-time OS? It will just define the way the system will work, and it does the execution of the application software. And some small scale systems may not have this real-time OS. Only medium and large scale systems will have this real-time OS. Thus, embedded system can be analyzed as microcontroller, software driven, reliable, real-time control system. So an embedded system is a microcontroller based, software driven, reliable, real-time control system. So we can define it as an embedded system is a combination of hardware and software doing a specific task. An embedded system is a microcontroller based, software driven, reliable, real-time control system. So it has a sensor, it has a to D converter, it has a processor, it has a D to A converter, it has an actuator. So these are the internals of embedded system. External are there is a sensor, there is an actuator, sensor connected to input port, actuator connected to the output port, and the internal part is the core, the processor, and this is connected to the memory. This is one example, washing machine and refrigerator, examples of embedded system. So embedded system is a unique system, application specific, tailored for power saving modes, response time may or may not be time critical, and execution behavior is deterministic. So this is history of embedded system which we covered. Coming to classification, based on the generation, complexity and performance, based on the deterministic behavior, based on the triggering. So as you have seen in our previous class, based on the generation, they are classified into first generation, second generation, third generation, fourth generation. So if you consider the processor, it is coming into four classification. If you consider the complexity and performance, it is coming under three classifications: small scale. So this is based on the generation: first generation, second generation, third generation, fourth generation, and certain examples are covered for each generation, which we covered in our previous classes. So coming to classification based upon the complexity and performance. So this is small scale, medium scale, and large scale. So there are some examples provided for this. This we have covered in our previous class. The main content of this class is we have to cover a topic called characteristics and quality attributes. As of now, we understood what is an embedded system, how it is classified. So classification is based on the generation, classification is based on the complexity, classification based on the deterministic behavior. It is soft real time and hard real time. Based on the triggering, it is event triggered and time triggered. So based on the triggering, it is event triggered and time triggered. So this you know, but still you go through our previous class, so you can come across this, you can understand. So these are the various application areas. Application areas based upon the products in each area, they are classified into consumer electronics, household appliances, automotive industry, home automation and security, telecom, computer peripherals, computer networking system, healthcare system, banking and real time, and card readers. So if you see under consumer electronics, we have seen certain examples like camcorders and cameras. So you know what is a camcorder, what is a camera. Similarly, under household appliances, it is washing machine and refrigerator. Under automotive industry, it is anti-lock braking system. Under home automation security, it is air condition system. Under telecom, it is cellular phones and telephone switches. Under computer peripherals, printers and scanners. Under computer networking, it is network routers and switches. Under healthcare, it is EEG and ECG. Under banking and retail, it is ATM machines. Under card readers, it is barcode and smart code. So there are large number of devices coming under into one category. So they are classified that category into as one area, like card readers, a barcode and a smart card. A smart code is used to authenticate a television. Like we have uh, a dish and we have to authenticate using smart card that you are the specific person utilizing the uh, box setup box. Setup box is activated by using a smart card reader. Similarly, an employee, he want to give his authentication by one ID card where some barcode is given. So that one, or any in flight control system, all the luggage with specific barcode will be given. That barcode tells that it is belonging to travel destination and a specific flight, specific um, flight company like SpiceJet or Indigo. So which flight they are boarding and what is the destination and where they have landed and they are to uh, where they are going to take off and there where they are going to land off. So every barcode is given on a barcode is printed on a paper and that is given to your luggage. So there they will scan it and they'll identify this is belonging to you. So we have seen our topic called purpose of embedded system, where we have seen that our embedded system is doing one task such as it is taking the input from the environment and external world, and it is giving an output as per the requirement. If you see the air conditioners, they are sensing the input temperature of the room and they are giving cooling to the room by internal logic. They are going to run the motors and the actuator gives output as airflow and such that room is given cooling. So for that, this embedded system has to serve the purpose by combining the following tasks: data collection, storage and representation. So we have to do one task called data collection, storage and representation, that is done by a digital camera. Data communication, that is done by a wired or wireless methods. Data signal processing, that is done by processing like monitoring like your ECG, control such as your air conditioners, application specific, these are the keyboards, buzzers, buttons. So all these topics were covered in our previous topic. So in this class we have to cover our last topic of first unit, characteristics of embedded system. So after seeing that there is an embedded system which is doing a specific task and having a hardware and software, we can specify a specific characteristics to these embedded systems because each embedded system is unique. As they are unique, the characteristics provided to them differ. So washing machine characteristic is to wash the clothes. Air conditioning it is to give the room temperature cooling. So some are real time, some are not real time. Some must be deterministic, some may not be. So based on that, different characteristics are provided, and your embedded system may have these characteristics or it may not have. So characteristics of embedded systems are application and domain specific, reactive and real time, operating in harsh environment. Fourth one, it is distributed. Fifth one, small size and weight. Sixth one, power concerns. Seventh one, single functioned. Eighth one, complex functionality. Ninth one, tightly constrained. 10th one, safety critical. So these all characteristics are acquired by your embedded system. It may or may not have one of these characteristics. objects. So first one is application and domain specific. What is application? Domain is the area. Under this, what is the application? So each embedded system has certain function to perform, and they are developed in such a manner to do the intended function only. So they cannot do other purpose. So the embedded control unit of a microwave oven cannot replace with air conditioner embedded control unit. So all embedded systems will have a hardware processor. Each processor has a control unit, arithmetic logic unit, and a memory, and the control unit tells the various control parameters, what is the inputs coming, what are the outputs going. So this all the control unit you can't replace with another embedded system control unit, because the embedded control unit of microwave oven and AC are specially designed to perform certain specific tasks. The control unit of a microwave oven tells to only heat the material in the oven, whereas the control unit of AC tells to only control the room temperature. So the control instructions are the sensors, reset buttons, or any signals given to the internal logic instructions, they all differ. So that's why application and domain specific means each embedded system is unique. So you cannot use control unit of one embedded system to the another. So all embedded systems are application and domain specific. Based on the application, they are designed like that. Air condition systems designed by one vendor, the control unit you can use for ACs provided by the same vendor. See, an AC of 1.5 ton control unit can be used for another AC by the same vendor of 1 ton unit. So because the major purpose is providing the room temperature, only thing is the capacity is changing, 1 ton or 1.5 ton. So control unit may be same, but the control unit of oven and AC will differ. The second characteristics is reactive and real time. So embedded systems are in uh, interaction with the real world, are in continuous interaction with the real world through sensors and some user defined input devices connected to the input port. So any changes in the real world will be sensed by the sensors, and the control algorithm running inside the unit is designed in such a manner to generate a controlled output variable to the desired level. So if this is the input, what is the output you have to do? If this is the room temperature, you have to cool it. If this is the room temperature, you have to make the motor switch off so that you maintain the room temperature. So they are reactive, they are sensing the input in the real time, and they are reacting to the world, external world parameters. So such way the characteristic is reactive and real time. And these embedded systems produce changes in the output in response to the input. So because they are changing the output, so if they are switching on the motor or switching off the motor, or running the motor fast or slow, that is related to sensing the input parameter and giving the changes. So that's why they are called reactive systems. And the real-time system means the timing must be deterministic, at what time it has to respond, that amount of time. So this comes under examples like critical mission control systems or mission critical systems like anti-lock brake systems are coming under these examples. So the another characteristics is called reactive and real time. So mostly all critical systems are reactive and real time, and non-critical systems are reactive, may not be real time. The third characteristics of an embedded system is it operates in a harsh environment. What is operating in a harsh environment? Because these embedded systems are placed in all the sectors, like they have to take care of the operating conditions such as temperature. At high temperatures they must be designed so that all the components will operate normally, and if any shock is occurring, in shock absorption techniques must be provided so that they must be subjected to high shock. Distributed. See, embedded system cannot be placed at one place. An embedded system placed in a military area has one logic of an embedded system like data collection, data storage, and representation. So for that, they have to place a digital camera in any remote area, or they have to send a radar signals, and that must be detected by your embedded system placed in a remote area. So automatic vending machines, it contains a large number of subsystems. They together work and they perform the vending task, and each of the tasks are independent. Another characteristics is small size and weight. So what is small size? Your embedded system must be small size and less weight. Next, power concerns. Uh, Power is because household appliances, industrial or military, everywhere, it is the main characteristic is power. So if it requires that you design such that you minimize the power consumed by the embedded system, then the user will prefer. If there are multiple vendors providing the same washing machine, refrigerator, they'll go for the star rating, and which is consuming less power, that is first selected. So any product, embedded system product designed must be seen that it has occupying less area, it consumes less power. Okay, then only it is preferred by the end user. So it is single function dedicated to perform a single function. And complexity, now we see that our embedded system does sophisticated functions, not two or three functions. If it can do multiple functions, sophisticated algorithms are written in the application software, so that you can make it more complex. So we prefer more complex systems, tightly constrained. So embedded systems are must be low cost, low power, small size, and they must be fast in its operation. Safety critical, must not be endanger human life and environment. See, any embedded system such must be human friendly, and they must provide comforts to the human mankind. They should not harm the human life. So that's why they must be designed to be safety critical. So these are the characteristics of embedded systems. So any manufacturer, if he is designing an embedded system based on the application area, he must satisfy all these 10 characteristics, so that we get a better embedded system product. And the next topic is quality attributes of embedded system. What are the quality attributes? Means these is the non-functional requirements to be documented properly in any system, and they are of two types. One is operational quality attributes, non-operational quality attributes. So any embedded system we judge based upon the quality attributes only. So operational quality attributes means once the embedded system is in use, we are operating on mode, then we'll see what are the how it is performing. Its performance is judged by these quality attributes. So one attribute is response, how your embedded system is responding, how fast it is responding to changes, and how fast it is giving the result in real time. So like flight control system, if it is tracking the changes in the input variables and measuring them and giving the response in fast, then we prefer such systems. So flight control systems quality attribute is response. Throughput, so throughput means it is output of any embedded system. So embedded system throughput deals with efficiency of a system. In industry side, you can analyze it as a rate of production, or a defined process over a stipulated period of time, and number of products produced. In case of card reader, number of transactions you can perform in a minute or in a day. Throughput is generally measured in terms of benchmark, and benchmark is a reference point. If it is crossing that reference point, we'll see that our embedded system is having a good quality attribute throughput. If it is not up to the benchmark, then that embedded system is not preferred, its throughput is less. Reliability. It is a measure of how much we rely upon functioning of the system. See, embedded systems are designed to be reliable, but sometimes they may not be performing well. So if that is occurring frequently, you may not prefer that embedded system. So those embedded systems which are performing well, those are only preferred. So that is related to functioning of the system. Mean time between error and mean time between repair are the two terms in defining the reliability. Mean time between failure are the frequency of failures in hours. So number of hours it is occurring in failure, that is MTBF, and MTTR specifies how long the system is allowed to be operating in out of the order. Okay, following a failure out of the order, how long the system is allowed to perform, that comes under MTTR. So for embedded system with critical applications needed, we prefer it should be in the order of minutes. Maintainability. So this quality attribute deals with the support and maintenance to the end user in case of any technical issues, product failures, or routine checkups. Reliability and maintainability are complementary to each other. More reliable system will require less maintenance and vice versa. Maintainability is again two types: scheduled or periodic maintenance for preventive maintenance, or corrective maintenance. Corrective maintenance means if there is a failure occurring, we call the maintenance person who will do the repair. Or frequently, regularly you can monitor, and periodically you can do the maintenance. But a reliable system will not require maintenance. Security. Confidentiality, integrity, availability are the three measures of security. So if you are achieving these three parameters, we tell that our embedded system is secure. What is confidentiality? It protects your data from unauthorized persons. Integrity, along with protection of data and applications from unauthorized modifications. So if data is not disclosed to another persons, that is called confidentiality. If data is not allowed to be edited, that is called integrity. Availability means it will not be allowed, that embedded system is not allowed for other users. You are allowing a person to use the embedded system. So embedded system will be switch on for that person, but it will not allow to edit the data. That is called integrity. It will not allow to provide the data. Okay, protection from the data and unauthorized disclosure. So you are unable to utilize the data, then it is confidentiality. You are utilizing, but you are unable to edit the data, that is called integrity. Or you are unable to provide the embedded system itself, that is called availability. So confidentiality, integrity, and availability are the three key features of an information security. So you can provide the embedded system to a user, okay, then confidentiality and integrity are built, but availability is not built. But if you are not allowing to edit the data, then integrity is not built. Okay, similarly, you are allowing to use it, but you are not editing it, then it is called confidentiality. Okay, you try to understand, there is an embedded system. That embedded system you are not allowing any person to use. Okay, that is called availability. But if you are allowing person to use and he can only view the data, then that is called confidentiality. Okay, integrity means you are not allowing to modify it. Next, safety. Safety deals with how what are the possible damages that can happen to the operator, public, environment due to breakdown of the embedded system. This breakdown of embedded system may occur due to hardware failure or firmware failure. And safety analysis, if any embedded system is due to environment, due to public, or due to operator, if it is damaged, how safe it is. Okay, so that is called safety characteristics, quality attributes of an embedded system. The quality is safety analysis is a must in product engineering to evaluate anticipated damages, determine the best course of act, bring down the consequences of damage to an acceptable level. And this breakdown may occur due to hardware failure or software failure. Non-operational quality attributes. Even the embedded system is not operating. What are the quality attributes? Testability and debuggability. What is testability? You can easily test the application. So that is testability, and testability is applied for both hardware and software. Embedded hardware testing sees that all peripherals, all firmware, embedded hardware testing ensures that all peripherals, total hardware functions in a design manner. Firmware testing ensures that software is functioning. What is debuggability? Upon unexpected behavior, you can easily identify that unexpected behavior. Debuggability is a two-level process. That is a hardware level and software level. Hardware level is finding the hardware problems. Software level is finding the flaws created by in the software. So first character is testability. So even device is not operated by any end user, you can test the device and you can debug it. Next, evolvability. It is a term which is closely related to biology. So non-heritable variation. What is evolvability means? You have designed an embedded system with one processor and some features, and same hardware features you want to create one more big design, complex design. So from the existing design, you are creating some more applications you are adding to the same embedded system. So that is evolvability. Portability means it is a measure of system independence. All embedded systems we prefer based upon the environment conditions. We prefer it must be portable. It is capable of functioning in various environments and temperatures and different OSs. So your porting means your embedded system must be able to migrate from one target processor to a different target processor. Time to prototype and market. It is the time elapsed between conceptualization and the time at which product is ready for selling. So time to prototype means you have an embedded system logic and how fast you can give it to the market. Okay, so that time to prototype, easily you can make the copies. Okay, one design you are having, so that is time elapsed between analyzing the design and product is ready for selling. And what is market means? The commercial embedded product market is competitive, and time to market the product is critical factor for achieving the success. There may be multiple players in embedded system industry, so your time to prototype and market must be as less, so that your product is available in the market as early as possible. Per unit cost and revenue. Cost is a factor which is closely monitored by the product manufacturer. Cost is highly sensitive parameter, and any failure, if you are unable to judge the cost and you give a random rate, that may lead to the failure of the product itself. And the market study and cost benefit analysis gives a decision for designing the per unit cost of the embedded system. The ultimate aim of the product is to generate budget. You have to generate the marginal profit. So your aim of the product is you have to generate a marginal profit for the vendor who designs the product. So budget analysis, total cost analysis, market analysis, all will decide the marginal profit. So that is decided by the per unit cost and the revenue you kept for an embedded system. So after covering this topic, we'll just summarize. An embedded system is an electronic mechanical system combination of hardware and software, and based upon the complexity, performance, generations, deterministic behavior, we have various classifications. This embedded system is designed to serve the purpose of data collection, storage, representation, monitoring, and control. And in our day-to-day life, we are using these embedded systems, and we prefer this embedded system technology to evolve so that every application is digitized, and those comforts the man can enjoy. Okay, with this topic, we will stop our first unit. Okay,